All right, so we're going to be doing integrals this time with exponential functions. So if you remember, the derivative with respect to x of e to the x is e to the x, which means the integral with respect to x would also be e to the x, and then you just add that little constant. So all the different problems that we do need to be in that form. They need to have that e to the x dx. So when we have these, you want to rewrite them. This is 3 e to the negative 5t dt. And then the rest I don't mind putting together. So this is t to the 1/2 minus 3t to the negative 2 dt. And you can split them up as well. So the last two are very quick to do. So we need to focus on this one. So we're going to put it up on the top. And we're going to leave the 3 down there. We're going to put e to the negative 5t. In fact, we'll put the 3 so we don't forget it. And then the way you handle these is you say u equals, and if you do 1, you already know how to do the rest. Negative 5t du equals negative 5 dt. dt equals du over negative 5. So you notice when I plug it in, I now end up with e to the u and then du over negative 5. So now when I finish this, I end up with negative 3/5 e to the u plus c, which is negative 3/5 e to the u, oops, not u anymore, negative 5t plus c. So you should see a nice little trick. So when I write this, it's just going to be negative 3/5 e to the negative 5t. So when you see that there's just a coefficient in front, it just goes underneath. Just like before. It should seem very, very familiar. When we had those exponents, you would just put the negative 5 down there. So that's all we're doing. So that way when we take the integral, the derivative would be negative 5 and it would cancel. So you can do it this way if you want, or you can just take that negative 5 and put it under there. That's it. And then we continue on. So 1/2, remember, we add 1. So that would be 3/2, and then you get 2/3 minus, and then we add 1. So we put 3 over negative 1 like that. So we add 1, so 3/2, 2/3, perfect. We add 1, you get negative 1. Put on the bottom with the 3, and then now we just have to rewrite it and add plus c. So negative 3/5 e to the negative 5t plus 2/3 t to the 3/2 plus 3 over t plus c. Now I don't mind you not rewriting the exponents for your rationals, but you do have to put the t back on the denominator. No negative exponents. Except for the e's. E's I'm fine with because they indicate decay. So you can still put it down there if you want as well. Okay. Now let's try one with U substitution. So you have a parenthesis here and a parenthesis here. And so when you pick your u, you always want to pick it for the e. Because again, we're trying to get it into that e to the u form. So we pick u equals sine theta. So du would be cosine theta d theta. So d theta is equal to du over cosine theta. And so now when we plug it in, everything should cancel. And there it is. So now we end up with, oops, didn't place my u in there. Perfect. E to the u, du, and everything is good. So now that would just become e to the u plus c. And what's my u? Sine theta. All right. This one is simplifying first, so it looks horrible, and so you would pick normally 1 plus e to the x, but then it would go down to the denominator. So if you have a square like that, that's not difficult to simplify, so we might as well just simplify it. So you're going to end up with 1 plus e to the x times 1 plus e to the x. And you can do these quickly, or you can do them slow. I'll take it slow here just for you. So we get 1 times 1, e to the x, and then e to the x times e to the x. And this is added, so it's 2x. So 1 plus 2 e to the x plus e to the 2x. Just like that. Okay, so we have 1 plus 2 e to the x plus e to the 2x all over e to the x dx. And then now we can just divide it. So the first would be 1 over e to the x plus, and the next one is just 2 plus, and then e to the x. They just cancel each one. So you divide the e to the x into each, and then now we want to rewrite. So integral e to the negative x plus 2 e to the x dx. Oops, forgot the plus. All right, so now when we take our integral, like I said before, this is just negative e to the negative x, and you can quickly check it with a derivative. So that would just be e to the negative x times the derivative of the top, which would be negative 1, cancels with the negative 1, takes us back, plus derivative of integral of 2 is 2x, and then e to the x plus c. And yes, you can put that as a denominator and bring it all back together if you would like, or you can leave it alone. Okay, the next one is a trick. And so when you look at this, you go, oh my gosh, well, if I take a u and make it an e to the negative x, don't do this, don't write this. But if I do this, no matter what, I'm going to end up with another e to the x, and there isn't one for it to cancel. So the trick is this. We need to introduce some e to the x's. So if you multiply the top and the bottom by e to the x, and where I'm picking that is I'm looking at e to the negative x. And I know if I multiply it by an e to the x, it's going to cancel it, because you're going to have one on the numerator, one on the denominator. This now gives me e to the x over 1 plus e to the x dx. Now I can say u equals, and you want to pick the bottom. It's the best place to pick first. Now du is equal to e to the x dx. So dx is equal to du over dx. Plugging that in. Just trying to get through these quick, so bear with me on my little mistakes. So divide by e to the x, it goes here, and you can see they now cancel. And so we end up with the integral of 1 over u du. And in the next section, you're going to learn what this is. The integral of 1 over u du is the natural log of u plus c. And so this is the natural log of 1 plus e to the x plus c. Now there's an absolute value that goes here. The reason I didn't pick it is because what I'm plugging in is always positive. E to the x is greater than 0. 1 is positive, so together they would be positive. I don't need the absolute value. And in the next section, you'll understand how to create the natural log. All right. Definite integral is the same thing as before, except now we're going to be using 0 and 1. So we want to pick something that is our u. And again, you always pick the inside of things. So we're going to pick that one right there. And so my du would just be 0, and then minus e to the negative x dx. And again, I'm doing these quickly because remember that number in front is just going to be e to the negative x times the derivative of the exponent, which is negative, and there you go. So dx equals du negative e to the negative x. And you look over and you go, oh crap, there's no e to the negative x. There is, it's a denominator. So what we're going to do first is rewrite it. E to the negative x. And then now we will plug it in. So 0 to 1, e to the negative x, square root of u, du over negative e to the negative x. And you see now they cancel. So we end up with negative integral 0 to 1, u to the 1/2. We want to always put it in that general power form. Okay, now we can't use this 0 and 1. It's standard thing to, it's like not standard, it's like common error to do that. We need to do is resubstitute. So we need to find out what u is for 0 and what u is for 1. So if I plug in 0, right, I get 0, that's 1 plus 1 is 2. And then now if I plug in negative 1, I end up with 1 plus 1 over e. So those are the numbers that we're going to be plugging in. So we're going to go from 2 to 1 plus 1 over e. Okay, now we can find it. So we're going to add 1 to the half, which is 3/2. And then flip it, put the negative in front. And then we get 1 plus 1 over e and 2. And then we plug them in. And there you have it. Now, one way is to check the derivative to check these. So if you take the derivative of this, we get e to the sine theta times the derivative of sine theta, which is cosine theta. So it checks perfect, and then c is just a constant. Same with this one, you can check it. And then this one's the same way, but we haven't done it yet. And so after we cover the derivative, then you're going to be able to check it, and it's not too long. Now, this one is very easy because you have the calculator. So we're going to plug this in the calculator, and then plug that in the calculator, and they should match. So let's do the first one first. So it's from 0 to 1, so math 9. And we go from 0 to 1, and then alpha y. Just make it look exactly the same. Second square root, 1 plus second e to the negative x, all over e to the x, and make sure it is correct. There's no negatives missing or anything else. X, and hit enter. So that's the answer we should be getting, 0.819. Now let's try our answer. So I'm going to move it over a bit so I can see it. There it is. So negative 2 divided by 3, parenthesis 1 plus 1 divided by e. Now you notice this e doesn't have an exponent. It was a 1, right? And so you just put it in there as well. 1 like that. Parenthesis. Exponent divided by 2 plus 2 divided by 3, parenthesis 2, exponent 3 divided by 2. Make sure everything's perfect. If it's not, we'll re-enter it, but you see they match perfectly, so we know we're good. That answer is correct. See, so when a definite integral, just plug it in your calculator, and it'll give you the perfect answer. Now you can also factor out the 2/3 if you want, and you could plug this in and give me the decimal. All right, thank you.